Hello and welcome back to Odds Physics. In this video, we'll be going over maximum height and the equation for maximum height and how it's derived as well as what it means, and some practice problems. Obviously, the more harder practice problems will be on oddslearning.com on the PDF, as well as a video I push out covering the harder questions on that PDF. But for now, let's get started. So maximum height, like I showed you, right? All the other equations were derived from one of the big five. This will also be derived for one of the big five. Vy final squared is equal to Vy initial squared minus 2g delta y. This is one of the big five, but warped for vertical motion. So if you look at my previous videos on vertical motion, you'll see this one. Now, imagine that delta y was my height. Okay, that was the highest point I could be. So it was height minus 0. So let's just say this was height, which means what? At my height, my velocity y has to be 0. Do you understand why? Because this is very important to understand, so make sure you pay attention. You can't take the slope of a parabola, but you can approximate the slope. Over here, the slope looks like this. There's a line that looks like this. Over here, the slope looks like this. There's a line that looks like that. And then over here, there's a line that looks like this. So this slope is pretty large. This slope is smaller. This slope is what? It's 0, because the velocity at that point, at the height, or the vertex of a parabola, is going to be 0, because it just doesn't change, right? That's where it hits a stalemate, and then it becomes a negative slope. But in order to become from a positive slope over here to a negative slope, it must first cross 0. So at the highest point in a parabola, the velocity y is 0. So this is going to be 0 squared is equal to velocity y initial squared minus 2g delta, or I could just replace it with h. Subtract velocity y initial squared from both sides. Divide that by negative 2g. And I'm done with my equation. So this is basically, I can also write this as, instead of writing velocity y initial, I can just say velocity y times sine theta squared, right? Because they're both the same thing. Sorry, not velocity y, sorry. Velocity initial, because velocity y is velocity initial times sine theta. Okay? So velocity y is velocity initial times sine theta. Well, velocity y initial at least. It doesn't need to be velocity initial, but in this case it is. That squared over 2g. And if I was to give myself some more real estate, this is h, right? So h is equal to velocity initial squared times sine squared theta over 2g. Pretty simple. You could obviously, just use this formula. You could just not use this formula and you could just substitute into this equation every time, which is fine. I just want to let you know that this exists and there's a way to derive it. And it can save you a lot of time, which is very important, right? Whenever you're in a test or you're doing homework, you want to minimize your time, but maximize your quality. And this will help you do that. And before I go anything further, right, you can just write velocity y initial squared over 2g, or you can write velocity initial times sine theta squared, which becomes velocity initial squared over 2g, because they're both the same thing. Velocity y is just velocity initial times sine theta. And then if you square the whole thing, it becomes velocity initial squared and then times sine squared theta. But now let's go over a practice problem. You launch at 30 meters per second, 60 degrees above the horizontal. Okay? 30 meters per second. So the initial vector will be velocity initial here is 30 meters per second. And this is not velocity initial y, right? Because this is just the vector you're launching at. This has components in both the y and the x direction. The component in the y direction would be this one. The component in the x direction would be this one. And find the maximum height h. Okay. We know h is equal to velocity initial squared times sine squared theta over 2g. In this case, velocity initial squared is 30 meter per second. So 30 meter per second squared, 900 meters squared per second squared, times sine squared of theta, sine squared of 60 degrees, all over 2g, or 2 times 9.81. So if you were to calculate this, and then of course I want to put my units here as well, right? Meter per second squared. Then obviously the units cancel out to make meters. 900 times sine of 60 squared gets me to 675. And then that divided by 2 times 9.81 gets me to 34.403. Approximately 34.403 meters. Pretty straightforward, right? In this case, what I showed on my slide here was we used velocity y initial squared. So we didn't do this velocity initial squared times sine squared theta. So the answer over here was a bit off, right? Over here I got 675 exactly, and they got 674.9. Similar, but since I used a different equation, same result, I mean basically same result, but tad bit different angles and stuff. Let's try a few practice problems, right? As always, more comprehensive problems at artslearning.com on PDFs as well as the video I'll be pushing out. So first take a try by yourself, and then I'll go over it with you. Okay, I'm assuming you gave it a try. Standard math height. So this seems like a regular equation. A projectile launches at 24 meters per second, 50 degrees from level ground. Find the maximum height h. Velocity initial is going to be 24 meters per second because they tell us that that's the velocity initial vector. Angle or theta is 50 degrees from level ground. Maximum height h will be velocity initial squared, 24 meters per second squared, times sine of 2 theta, sine squared of 50 degrees over 2g. Or I can just replace this with 9.81 meter per second squared. Now you do that, and you get, so 24 squared times sine of 50 squared is 338. Divide that by 2 times 9.81. You get around 17.23 meters. That's your height. There you go. Now, something you want to keep in mind is there is a way they can trick you here, right? Remember when I said from the vertical, not from the level ground? So it could be that they say 30 degrees from the vertical. Then you're going to have to swap the angles, right? So you have to write 60 degrees here. So always be aware of those traps, okay? You want to make sure you read every question right, because in projectile motion, there's a lot of ways to trick you. The only way to counter that is by reading it straight and making sure you're paying attention to every word. In this case, it was normal, but obviously I'll go over cases where it's not in my other video. Now let's try working backward to the speed. Matt's height h is 20 meters. Find Vy initial, then the full speed Vi if theta is equal to 55 degrees. Okay. So here I'm probably not going to use Vi squared times sine squared theta, right? because it's just VYI. So h, or 20 meters. So if I was to write h is just equal to 20 meters, we know that. And theta is equal to 55 degrees. If you use a height formula, VYI squared over 2 times 9.81. So 20 times 9.81 times 2, and square root of that. Approximately 19.81 meter per second is the magnitude of velocity y initial. Now we know that this is velocity y initial, right? So it's going to be velocity initial is equal to velocity, so sine theta times velocity initial is equal to velocity y initial. So 19.81 meter per second is equal to sine of 50 times velocity initial. Then we can divide, 55. Whoops, 55. 19.81 divided by sine of 50 degrees. So you get velocity initial is 25.86 meters per second. This is velocity y initial. So you see how you can use both formulas, velocity y initial squared, and then you can do vi squared over sine theta squared. In this case, I used the other one, but there's a way to solve it using the vi squared over times sine squared theta. So same speed, angles 30, 45, and 75 degrees. Rank mass height using only the sine squared theta relationship. So that's basically assume vi squared, or so assume vi squared is constant. So sine squared theta. And 2g is also constant. So assume these are all constant. And just find this. So what value is sine squared theta going to have the maximum value for? Sine squared 30 is what? So sine of 30 squared. Well, sine of 30 is pretty low down here, right? It's pretty low. So I'll rank it as low. Sine of 45 squared is over here. So that will be medium. But sine of 75 is up here. And that's going to have the highest value for sine of theta. So when you square that, it's going to have subsequently the highest value. 75 degrees is the max height. So there's always a trade-off here, right? When I was going over the range formulas, I showed you how the range, the optimal is 45 degrees. But for height, if you want the highest height, you just have to keep firing it higher and higher. So there are trade-offs between both of those. Otherwise, great job following through, and I will be going over harder problems as well as PDFs that I'll be sending out. So don't worry, this isn't the last you'll see of kinematics if you're feeling unsure. But if you want to review, make sure to look at my other videos, and I will have a more comprehensive practice problem video I'll be going over. And you can look at that as well. Thank you for listening.